250,000 tons. That is not the weight of a building. That is not the weight of a bridge. That is the gross tonnage of a single ship that left a shipyard in Finland in late 2023, and it floats. Not barely floats. Moves. Turns. Docks itself at a pier without tugboats. Keeps nearly 10,000 people fed, showered, and entertained in the middle of the Caribbean Sea. Before this video is over, you will understand exactly how that is physically possible, and a few of the answers are going to completely contradict what you think you know about how ships work. If you are watching this for the first time, tell us where in the world you are watching from down in the comments. And if you want more videos like this one, the subscribe button is right there. It takes 1 second, and it means you will not miss what comes next. Icon of the Seas is the largest passenger vessel ever built. Not the longest, not the tallest, the largest, measured by gross tonnage, which is a volumetric figure that captures the total enclosed usable space inside the hull and superstructure. 250,800 gross tons. To feel that number in your body, rather than just read it, imagine loading 170,000 mid-size cars onto a single platform. That is roughly the displacement you are dealing with. And every single one of those cars, stacked and packed, is somehow resting on a steel hull moving through the ocean at 22 miles per hour. The hull itself is longer than 3.5 American football fields placed end to end. It rises 20 decks above the waterline. Stand at the stern and look forward, and the bow is so far away that in light fog, you genuinely cannot see it clearly from the same deck level. The ship is not a large version of something familiar. It is a different category of object. Here is where the engineering starts to get genuinely strange. A 20-deck superstructure sitting on top of a floating hull should, by every instinct you have, be catastrophically unstable. A building that tall would need a foundation driven deep into bedrock. Icon of the Seas has no bedrock. It has seawater. The answer is in the proportions, and the proportions are almost offensive when you see them clearly. The hull of Icon of the Seas, the actual steel shell that sits in the water, is proportionally thinner relative to the overall size of the ship than the aluminum wall of a soda can is relative to the can itself. What makes it stable is not thickness. It is geometry, weight distribution, and a draft of 30 feet below the waterline that plants the center of gravity deep enough that the entire structure resists rolling the way a weighted buoy resists being pushed underwater. The deeper the keel, the harder physics works to keep the top side up. The engineering team at Meyer Turku, the Finnish shipyard that built her, spent years on stability modeling before a single plate of steel was cut. Every amenity placed on the upper decks, the water slides, the aquadome, the above deck pools, had to be accounted for in the weight distribution calculations as a potential threat to that stability equation. Adding a 30-foot water slide to deck 17 is not a design decision, it is a structural negotiation. Now here's the part that almost nobody thinks about, and it is genuinely counterintuitive. A ship called Icon of the Seas. A ship carrying 6 themed water parks, the largest indoor pool complex ever built at sea, a waterfall feature, surf simulators, and enough swimming pools to fill a small municipal recreation center. And the single most persistent engineering challenge aboard that ship is keeping water out. Not ocean water, the ship's own water. A vessel this size carries roughly 525,000 gallons of fresh water in storage at any given time. The water parks alone recirculate millions of gallons continuously. Every drain, every pipe joint, every pump seal on 20 decks represents a potential failure point in a system that runs 24 hours a day, 365 days a year. A water leak on deck 5 of a hotel is an inconvenience. A water leak inside a steel hull at sea is a structural and electrical emergency. The engineering required to move that volume of water safely around, through, and off a floating steel city without any of it going where it is not supposed to go is as complex as the propulsion system sitting underneath the hull. Speaking of which, What is actually underneath Icon of the Seas is not what most people picture when they imagine a ship this large. There are no conventional propeller shafts, no mechanical drivetrain running the length of the hull from engine room to stern. Icon of the Seas is powered by an integrated electric propulsion system, the same fundamental approach used on the Queen Mary 2, scaled up to meet a power demand that is almost impossible to frame without a comparison. At full capacity, Icon of the Seas requires enough electricity to power a city of roughly 100,000 people, not to move the ship, to run the ship. The propulsion is separate from the hotels, restaurants, water parks, theaters, and life support systems that all draw from the same generation network simultaneously. 6 diesel-electric generators and 2 additional units provide the total output. That electricity flows to 3 Azipod propulsion units mounted below the hull, self-contained electric motors inside streamlined pods on rotating columns. The pods turn to steer. They reverse to stop. They vector thrust in any direction to hold the ship at a pier in crosswind conditions without a single tugboat. Icon of the Seas docks under her own power at ports that a ship this size 50 years ago would have been physically unable to enter. The speed is 22 miles per hour at service. That sounds modest for something consuming this much power. The reason it is not faster is not the engines. It is the water. Hydrodynamic drag on a hull this large increases exponentially with speed. The energy required to push Icon of the Seas from 22 to 26 miles per hour would demand a proportionally enormous increase in fuel consumption for a modest gain in arrival time. The engineers chose the number that sits at the efficient point of the power curve and built the itinerary around it. And the itinerary is what makes Icon of the Seas fundamentally different from an ocean liner in ways most people never consider. This ship does not cross the North Atlantic in January. It does not hold a fixed schedule against 30-foot swells and 60-knot winds. It runs Caribbean loops between ports that are 200 to 400 miles apart, in waters where the wave environment is manageable and the weather window is predictable enough to route around. The entire ship, its draft, its hull form, its superstructure proportions, was optimized for exactly that operating environment. Calm water, short legs, maximum passenger experience per square foot. That is why the draft is only 30 feet. An ocean liner built for the North Atlantic sits 34 feet below the waterline because it needs that low center of gravity to survive waves that Icon of the Seas will never be asked to meet. 30 feet is the correct answer to the question Royal Caribbean was actually asking. A different question gets a different hull. What it takes to keep 10,000 people alive and fed inside that hull is its own category of engineering. Icon of the Seas carries enough food for roughly 40,000 meals every single day of a sailing. The supply operation before each voyage is closer to stocking a military forward operating base than loading a hotel kitchen. Fresh water is produced aboard through reverse osmosis systems that process seawater continuously, reducing dependence on port resupply. Waste, food, human, chemical, is processed through onboard treatment systems that must meet international maritime environmental regulations at every point in the journey, regardless of where in the ocean the ship happens to be. The ship is not a floating hotel. A hotel sits on land with a city's worth of infrastructure feeding into it. Icon of the Seas carries the infrastructure with her. Every system that a city provides from the outside, water, power, waste processing, food supply, exists inside that hull in self-contained form, running continuously. Maintained by a crew of over 2,000 people, while the passengers who outnumber them nearly 4 to 1 have absolutely no idea any of it is happening. 250,000 tons. 6 water parks. 10,000 people. 30 feet of hull below the Caribbean surface. A power plant underneath the waterline, and a city worth of life support running invisibly behind every wall. Icon of the Seas is not the biggest version of a cruise ship. It is the point at which a cruise ship becomes something that needs a completely different word. And if that idea interests you, the idea that size eventually forces a machine into an entirely new category of engineering, there is a ship worth knowing about that was built around the exact opposite design philosophy. Not the biggest, not the most passengers, just one requirement: cross the North Atlantic in January on schedule, regardless of what the weather is doing. The engineering decisions that came from that single requirement will change how you look at every ocean vessel you ever see again. That one is already on this channel.